Good morning, everybody. I have the pleasure to present to Professor Guido Ferrari. He's an applied statistic recognized internationally as a leading scholar, a researcher in price indexes theory and practice, national accounts, demand model, equivalent scales, and environmentally extended national and regional equilibrium model as a support to public and privacy maker decision. He is an IC elected member since 1989 and a member of a number of international scientific organizations. Expert and team leader for more than 20 years in EU FAIR, TACIT, and MedStat, as well as FAO, WB, and ICT, international projects for statistical assistance to developing countries. He is a professor of statistics in the University of Florence and chair of quantitative analysis for business and economics of the Renmin University of China and scientific advisor in its Global Research Center for Low Carbon Analysis. Aguera's leading talent by Suzhou government and honorary professor of the Chinese Academy of Social Science. Professor Guido, welcome to Toledo again, and we are expecting about your conference about China air pollution, its consequences, social and economics. Of course, very important subject. Thank you very much for your conference.
Thank you very much, Madam Vice Chancellor.
No, it's okay.
It's okay. Good morning, ladies and gentlemen, and let me first thank friends and good friend, Professor Francisco Saiz Martinez, for inviting me and hosting this beautiful city, beautiful organization, for what I congratulate. I hope to give a small contribution to the discussion. This morning, I will deal with the problem of air pollution in China with the paper, which is not that research paper, but more a report to show how things are approached in China as regards air pollution, particularly by the center I belong to, the Global Center for Research Center for Low Carbon Analysis, set up by Renmin University of China some 10 years ago, which I'm a member. So I will say something about, quite general about the situation in China, because this is very important, not only for China, but also for the whole world, because China situation also for environment impacts on the world system. Also, I tried to emphasize my belonging to the center, to the Global Research Center, more than Florence University, just to give to this speech the content I want to give it. Okay, let me start with, also I tried to be not that conventional, but a little bit unconventional, and instead of doing the classic, the usual listing of introduction and the content and so on, I tried to put things in with reference to the dragon. China is a dragon. And so as for the generalities and introduction, I wanted to refer to the breed of the dragon just to describe the overall situation. As air pollution in China represents the crucial environmental problem and the central government is facing currently and is committed to face for the future. This air pollution depends basically on many things, but I list the three more important. The most important are, first one is the massive need for electric energy China has. because, as you know, China is developing very fastly and increasingly needs energy, electrical energy, to sustain this growing up. The second one is the quick motorization, both private and public, which took place in recent years, more than 10 years. This pollutes a lot. And also the third big reason is because it's represented by the heating system, particularly in large cities, which impact heating or cooling system in summer, or depending on where the cities are in big buildings and the skyscrapers and all over. Also for private houses, because in China the heating is made by using coal, and coal is not, at least the coal produced domestically, is not very good quality. Sometimes the imported coal is much better. The domestic coal is not good quality, so it produces a lot of particulates and other emissions, bad emissions. That's the burning of coal that produces carbon dioxide, and these emissions are very dangerous and create strong concentration of dioxide in the atmosphere. That's the reason why I said before we should be noticed that the problem of China as far as air pollution is concerned is the world problem, is an earth problem. Just to continue to introduce, to remain into the breath of the dragon, coal burning produces also variable quantities of sulfur dioxide, depending, as I already stressed, on the place where it has been mined. And this, in turn, produces acid rains. Yesterday, the friend Danny Ellerman talked about, he's an expert of that, and he introduced the problem of acid rains, which heavily impacts on the life of China. There have been estimates made by governmental organizations such as the one I quote here, that lung cancer is very, very heavy in China, and it's a very awful problem. In 2009, the lung cancer was the most common cancer in the country and in urban areas. So you can imagine how government is concerned with this problem. And it was the second most common cancer in rural areas. It is very easy to understand why. This is a confirmation that the main cause is coal burning. In the countryside, in rural areas, the coal burning is lower than in the big cities. And it is the leading cause of cancer death, both in males and females, urban and rural areas. So the problem is very big. And in 2008, this kind of cancer replaced liver cancer and became the #1 cause of death among people with malignant tumors in China. Again, the air pollution is the major risk factor for lung cancer in China. The registered lung cancer mortality rate increased by 464.84% in the last 3 decades. It's a huge increase. This imposes a huge burden on patients healthcare professionals and society. Once again, this is just to confirm the relevance of the problem. And the risk varies within China. It's of course, because it is, once again, this is a confirmation of the origin of the lung cancer. The risk is higher in Eastern China. Eastern China is more populated, very much industrialized, and it burns a lot of coal. And Eastern China is more affected, especially women, more than Western China. The crude mortality rates in 2008 were 47.51 per 100,000 for men and 22.69, much lower, per 100,000 for women, quite a half. It is highest in Shanghai, and this is important because Shanghai, as you know, this year some of you were in Shanghai for the conference on tourism, joint conference on tourism, and then you could have checked the importance of the industrial development there, and as a consequence, the air pollution. And these are the figures of the situation: 76.49 per 100,000 men, and 335. It's quite once again half for women. It is lowest in Tibet. This is reasonable. And in Ningxia, these are provinces less affected by where the coal burning is less, and so they are less affected by lung cancer. To summarize, the dragon's breed is wheezy, and urgent medicaments are needed. And so I passed now to the diagnosis and prognosis of the dragon. How is actually the situation, and what can we do to that? And what is the contribution the Global Research Center for Low Carbon Analysis can give, and actually is trying to give? Carbon accounted for 60 to 70% as an energy source in China, according to the State Statistical Bureau of China. China burns more coal to produce electricity than the United States, Europe, and Japan together combined. It's incredible, this. And is the largest contributor to emission of greenhouse gases in the world, by giving off more carbon dioxide than 3 United States put together. These figures are impressive. There is a big contradiction in China. China needs to support the development growing up, because also we all know that China is in a big competition with the United States to take the top level in economics in the world. So China needs to support and sustain its development heavily. But then, at the same time, when doing this, it pollutes more. So it's a secular problem. They pollute more to have more GDP. More GDP creates more pollution, but to sustain GDP, there is the need to continue. And so it's a very contradictory situation which should be solved. Just to give you another figure, the levels of particulate matter in the air of urban areas are 3 times what is stated as unacceptable in the European Union by us in our countries. Of course, China's air pollution impacts on the temperature rising Earth's atmosphere, and in turns, this global warming affects the environment. It is what we are discussing. and the additional problems it causes are fires, the forests burn, and other problems in agriculture created by the global warming, massive rainstorms, again with acid rains and floods. In China, floods are very frequent, more than in the past, due to this problem, and also it's linked acid rains. Up to a few years ago, there was not a great concern of this kind of problems. I remember, I'm very familiar with China since many years, and I many times wondered why the people, government, firms, nobody cared about pollution, air pollution, but not only air pollution, I'm talking about air pollution, but also water pollution is probably even worse in China. But now air pollution is the number one, because you may drive the car for tens of kilometers in China. It happened to me. And you are in a cloud. You think you may think it's fog, it's a cloud, a low cloud, but it is actually it is smog. It's impressive, and so and now due to this also ordinary people discovered had finally, at least the perception of the importance of the problem, and to try to avoid this massive coal burning. It's not easy because, as you know, China doesn't have alternative energy sources. The coal is by far the most important. But as a consequence of this new feeling towards the coal burning problem, the power plants and other industrial projects face opposition. And recently, above all in the areas now we will see, in the southern Shandong province, Guangdong, Shenzhen, there have been new projects that have been cancelled out due to the pressure made by the population. And in the meantime, parallel to this, impressive progresses are being made in installing filters in massive coal-fired power plant fleet, but this is not enough. And also in private houses, you can see, and I will talk about, I will touch it later on, new photovoltaic everywhere, but it's and so all the levels of sulfur dioxide and total suspended particulates, particularly PM10, they have declined since the 80s. China's cities still rank among the most polluted in the world. They are really very polluted. Not that Shanghai, some of you may remember Shanghai, but cities like Taiyuan in Shaanxi are impressive. People are in danger all time long because you are in a fog. And as I remember, just to give you some curious things, information, for many years, during many years since the 80s, I never saw the sky color in Beijing. I didn't know what was the color of the sky in Beijing. But recently things changed, but There is now a figure which gives the average of the suspended particulates in 34 major cities in 2005, but these are averages, just to give you some pictures, some idea, the average, so it's an average along the time. The PM10 concentration levels in northern cities is higher than in southern cities. This is an average. It's because you have here. Let's take Beijing. Beijing is 140% on average. It's curious. Curiously, Lanzhou is a very rural agricultural city. It's the capital city of Gansu province. It's very high on average. It's curiously, and in the south it is different, but also, of course, Changsha is not very industrialized, but Chengdu is, and also Hangzhou is Canton. Nanjing is not far away from Shanghai, and Wuhan is a big city in the center of China. Particulate concentration show everywhere downward trend from the 80s until the 90s, and then remained relatively flat. Also because the interventions. Greenpeace organization estimates that fine particles, atmospheric particulate matter, PM 2.5, the air pollution from this coming from 96 power plants in operation in Guangdong province is the south. Not southern, is the province where is Guangzhou, is a very industrialized province. And Hong Kong is not far away from there, caused nearly 3,600 premature deaths, as well as 4,000 cases of asthma in children during 2011. In addition, it is expected, but this is an expectation, and anyway, this new plantation has been cancelled, has been suspended. New coal-fired plants under construction are expected to, plus another 11 being planned, but this is theoretical because they are under discussion and probably they will be cancelled. The impact on air quality produced by this is expected to be 16,000 to produce 16,000 premature deaths and 15,000 child asthma cases in Guangdong and Hong Kong over the next 40 years. But I quoted this just as an information because it's very unlikely that these new plants will be implemented. Also, indeed, also this air pollution is a major risk factor in these two provinces, very industrialized, for stroke, heart attacks, lung cancer, and chronic respiratory diseases. So, after this very rough diagnosis and prognosis, what's the therapy, what China can do, and actually, in many respects, is doing to remedy to this situation. First of all, it's not conventional. It should be recognized that the Chinese leadership and government has been seeking to curb coal consumption and to solve pollution problem, and at the same time to meet the ever-growing demand of energy. We will discuss this when we will talk about the GDP growing up in the last 10 years in China. But government pushes the country to develop renewable energy sources, to move away from coal. And it pushes and it provides financial support for wind plant, photovoltaic, solar photovoltaic. As you know, this is another reason of pollution, but not partly air pollution, but more water and land pollution. The production of photovoltaic panels, now it's nearly totally concentrated in China. And biomass is also sometimes combined all together, each other across development to try to give some result, to provide some result. And in this policy, there is a plan set up by Chinese government, including a ban on approving new coal-fired power plants in key economic regions. I said before, for example, the debate in Guangdong and Hong Kong areas is very strong, and it's on the floor, and the government, of course, has a word in this, and has ambitious targets to cut coal consumption in Beijing, Shandong, and Hebei provinces. Hebei is not far away from the Beijing. These three provinces in China, as you know, means countries, because they may have 80 million population, 100 million population, 60 million. These three provinces consumed more coal in 2011 than all of the European Union. So you may have an idea of the problem. It's an example of this policy. You may notice is connected to the Olympic Games in Beijing. When there were the Olympic Games, 2008, the Olympic Games, Beijing was very much polluted. Government tried to present at least the capital city in a good shape. And so there was a big effort. There was a $70 million spent to close down factories or to put factories out of the city area. And actually there is a new industrial park in Beijing, which is impressive for its efficiency and effectiveness, but it was a consequence of the Olympic Games, and as a consequence, the air pollution decreased a lot, and it was the first time, as I told you, I could see the color of the sky in Beijing, and it was very, very blue. It was a surprise for me. I would expect that it was blue because sky is blue all over the world, but for Beijing it was new because nobody, the young people never saw the sky color in Beijing. But it is curious because there is another curiosity. According to some report, some investigation, about 13% of Beijing's harmful particulate matter comes from barbecues, cooking emissions. So, as you know, in China, barbecues are very, very popular. You can walk around the streets, and you can eat barbecues everywhere. It's very, very common. And it is estimated that this produces some 13% of the air pollution in Beijing. So the government instated a ban on barbecues in outdoor spaces in 2000. This has raised a debate, a controversy in Beijing, as the Beijingers called for, it was an empty talk, and they said that they question why the government doesn't focus on their effort instead on more notorious offenders, such as, once again, coal production and the construction sites. Also, construction sites is very important. Now, after the therapy, this is the focus of what I want to tell you this morning, and also the focus of the activity carried out in our center, the cost for Dragon. In recent decades, as you know, everybody knows, China achieved rapid economic growth, industrialization, and urbanization. It's very, very well known. The annual GDP growth was ranged from 9 to 10, even more percent, even more sometimes. In some years it was 14%, even 15%. And this was very beneficial for millions, hundreds of millions of people in China. This is also a reason why before, up to a few years ago, there was not people concerned on the problem of air pollution, because people wanted first to become rich, to become rich more, to be less poor than before. And so development, economic growth in China is accepted and it's welcome in the population. And this contributed to take hundred millions people away from poverty. And so there is a big debate on the sustainability of GDP of China growth, but there is agreement that this growth despite the global slowdown, economic slowdown since 2007, there is agreement that China already recovered. It was the first country in the world to recover from in Europe, we didn't recover yet. And that this 7-8% every year GDP growth will be sustainable until 2020. So this is, but this in turn will create new environmental problems. This is what I said before. But now it's time to also to say that this is growing up environmental problem, but health, economic, social problems caused by this. This is what I want to discuss now. These costs are very easily, this is not an exhaustive list, but we agree on that diseases and deaths that affect regional and national and regional health system. In terms of economic costs, it's very heavy, because there are a lot of diseases connected to the air pollution and the deaths, as we said already, because more medicaments, more doctors, more hospital beds, staff, and so on. So that, I would stress again that we are speaking about 1,350 million people. These numbers are impressive, and of course, everything should be calibrated to this scale. Cleaning up and abatement costs, carbon taxes on firms, agricultural damages, lower productivity in industry, services, and agricultural sectors, working days lost, there is a losing of working days. This is not completely negative because the cleaning up and abatement activity in turn produces earnings. So it's because it produces work, additional jobs, additional investments, but of course the most important aspect is that they are costs. They in a negative way affect the situation. And also services interruption, delays, households' life troubles, and households are massively affected by this. And another risk, very big risk in China, is the disruption of the country, ever present. And so we can say that air pollution, I'm speaking about air pollution as I said at the beginning, is very dangerous not only for health, economics, but also for social life, for political life too. This affects the core of the paper I'm presenting to you, and of the activity of our center in Renmin University is interrelated. There is cross effects in this. Everything is linked. So the main way for us in our project to approach it is to use a global, an overall approach, a comprehensive approach, and now I will tell you, but which is given by the equilibrium model analysis, the general equilibrium model analysis, which allows us to take account of the interrelationships between all the, and to model and to make simulations on the impact of the air pollution on the life, economic life of the country, and there are many ways, and just to quote, and they have been implemented to reach these results and to check, to make the analysis on the economic costs. Economic means also health, because health, as I said, transforms into economic costs. A method, I'm going very quickly to the end. There are many different methodologies and approach. One is this, those response functions. You can estimate different crops and regions within China by showing that it was done. I give you it's been done, some figures. The cost, because this is a way to estimate the cost for about 30 million RMB in 2003. It was equivalent to, at the time, in exchange rate, not in purchasing power. I will give to you figures in purchasing power later. It counts for 35, more or less, million US dollar million. And about 80% of this economic loss, according to this research, was associated with the lower vegetable yields, so in agriculture, and nearly 50% nearly 50% only Hebei, Yunnan, and Shandong. Once again, they are quite cultural, agricultural provinces. The total cost. No, this is the same as I said before. There's another approach, is a conservative estimate. According to this, was used by World Bank and in 2007, but it is referred to 2003 situation, and once again it deals with, but I just want to tell you that in terms of impact on GDP, what is important for us, leaving aside the billion RMB and the other things, it impacted if we assume that the present value of the per capita GDP over the remainder of the individual's lifetime, the economic burden of premature mortality and morbidity accounts for 1.16% of GDP. That's a huge share. And if we change, if a World Bank change the hypothesis and assume that the value using is valued, the value is a statistical life of 1 million RMB, the yuan RMB, reflecting people's willingness to pay to avoid mortality risks, the damage is 3.88% out of GDP. There is another approach, C approach. This is what I'm focusing. It is called integrated assessment models, computable general equilibrium models. This is what we are doing actually, because it allows us to have a comprehensive, to carry out a comprehensive analysis. There was at the beginning a model called the EPPA, it's Emission Prediction and Policy Analysis Model, which was used by these authors to model to the impact of ozone and the particulates concentration increased from, this is, okay, 1997 US dollars billion. It's referred to its constant price, 1997. It was 22 US dollars billion in 97, and it became 112 billion in US dollars in 2005. But remember, all in 1997, at 1997 price, that means constant price, 1997 constant price. In relative terms, in a proportion, welfare losses from air pollution decreased from 14% to 5%. It is apparently because of course there was the changing in salaries, prices, but in relative terms it decreased, but actually it increased. But of course in relative terms there was the changing in the system, and also in addition, particulate matter pollution alone led to a GDP loss, a pure GDP loss in 1997 US dollars, accounting for 64 billion in 1995. This was obtained by using the conventional static methods, neglecting the cumulative impact of pollution caused welfare damage, and this is likely the reason of not completely good estimate. This estimate can be improved, and we did that very briefly. I'm sorry to take too much time. Through the computable general equilibrium model and the related simulation. As you know, just to be brief, the computable general equilibrium models are based on social accounting matrices, and through social accounting matrices and other information, but sometimes only through social accounting matrices, you can solve the model and get the result, get the relations, the coefficient to measure the impact of different stimulus on the economy on the sectors, in this particular case, the impact of air pollution. As was used at the beginning, the EPPA version 4 of the model calculated the incidence and overall cost of each health outcome, and 4 scenarios have been set up. I briefly tell you, just to tell you that I don't want to be too boring to you, because I said at the beginning, this is not a research paper, but a report paper instead. But just to give to you the scenarios, there were four policy analyses. The first one was the most important, by assuming that ozone and PM10 concentration levels was at the historical levels, and the GDP values that and in this assumption the model, but not the model we introduced, but the EPPA HAE model has been calibrated to solve. Calibration means, as you know, solution. It's a way to solve the model. Then there was a second scenario which was not used. Fourth scenario were to make policy. Just to shift to the simulation results. Simulation results, due to this basis on this model, show that air pollution has produced substantial socioeconomic costs in China. Let's take two main points. The households, basically, but 2 points, consumption and welfare. They are very important. In terms of consumption, for the 3 decades from 1975 to 2005, air pollution reduced annual consumption levels, so households' consumption levels, between 7% and 23% according to the year. There are big reduction in consumption due to air pollution. The consumption loss in this period, the loss continuously increased in between the two limits, two bounds, 7% and 23%, and it increased from US dollars 16 billion in 1975 through 24 billion US dollar billion in 99 and to 69 billion in 2005. In relative terms, it declined, but we said already that relative terms are not important here. It's just to give, because the economic system changed, unemployment, condition, prices, salaries, important, very, very much important. In terms of welfare loss, there is a similar trend. So also, between 1975 and 2005, the loss in welfare grew from US dollar 22 billion to US dollar 112 billion every year. Again, and I'm going to finish, I give to you the last information, still as regards the costs. This is the model we implemented in our center. It's based on ISM, means extended social accounting matrix for China. We took a matrix, a SAM already estimated for China by Xi and Saltman in 2000, but it was referred to 1990, and we updated it to 2012 by using generalized cross entropy. This is a methodology which allows us to update by putting the totals of the matrix, we put the new, based only on the information on GDP, by sector, of course. In 2012, we were capable to update this matrix, this SAM, using generalized cross-entropy. Okay, I don't tell you the methodology is quite complicated because also we used generalized maximum entropy. The model was solved and it confirmed on average, we still are working on that, so these are the first results, provisional, very provisional results. Also, there is evidence that the government, that's very important for China, environmental policy is going to be effective for at least some production sectors and for households, but it's the very beginning. It's not very clear yet, but it seems that the direction might be that. So at the end, what's the situation? So what's up, Doc? There is the perception, government knows that this situation is no longer sustainable and bearable. It should change as soon as possible. This is no longer acceptable because there are too many diseases, too many deaths, too much GDP share that must be addressed to cover the underlying phase, too many costs to abate and clean up, too many costs in terms of lost working hours and reduced productivity, and in terms also of households' bad life quality, and therefore bad life quality of the society as a whole. I took the time just to conclude. I want to give to you an idea of the millenary wisdom of the Chinese people, because I wrote before and I told you as soon as possible, or at least in a short, medium, but short period should be improved, the situation. But as you can see, the Chinese philosophy is interesting because when you speak about, there was a conference discussing about short, long, medium term, and leaving aside Keynes, the deputy governor of the People's Bank of China, when asked on how long the short run might be, he said, "How long is the short run, you ask? You must understand, China is 8,000 years old. So when I say short run, it could be 100 years. So just to give you, to conclude, this is the conclusion. I thank you very much for your attention.
Thank you.